All right, so starting with problem number 3. They are still both set up. We have two equations, right? One of them isolates my y, and it tells me what my y is equal to. And we're still going to use substitution method. So I'm still going to circle what y is equal to, but draw an arrow to where the y is. I want you guys to remember, when it's just y or just x, put that 1 there, because that helps you understand what it is that you're multiplying by when we use our distributive property. Yesterday, some of you struggled with that type of a problem. So as long as you put that 1 there, add the 1, that's going to help you visualize it when you rewrite your problem. All right, so let's go ahead and rewrite problem number 3, because we skipped 1 and 2. We're crossing those off. We're not even going to touch them today. I'm going to rewrite my problem with 2 times x minus 1. Okay, I want to put that 1 there. Now where y goes, I'm going to start my parentheses and include 2x plus 3. Close my parentheses and then finish it with equals negative 3. Putting that negative 1 there was super duper important because we're going to end up multiplying everything by this negative 1. Okay, so then I'm going to go ahead and follow my steps, right? I have to eliminate parentheses, right? Bam. And I'm going to use distributive property to do that. So I'm going to multiply negative 1 times 2x and negative 1 times a positive 3. Okay, so I'm going to bring down my 2x. Negative 1 times 2x becomes what? Negative 1 times 2x becomes what? Jordan? Positive or negative? Negative 2x. Negative 1 times 3 becomes negative 3. And then we're going to bring down that equals negative 3. Okay, so going down my list, do I have any like terms to combine? Yeah. What can I combine?
Positive 2x and negative 2x.
Okay, and when I combine those, what do I get?
0.
I get 0, so I'm just going to cross them off for now. What am I left with here? Okay, so I just eliminated my x. So if it is equal to each other, right, I have a special answer, right? So this tells me that any number, any variable is going to work. So the lines are identical. If I laid one line on top of the other, they would be right on top of each other. So that gives me that special solution. What is that special solution that's going to work for this? Not no solution. It's the other one. Hannah? Infinitely many. So this one's going to have infinitely many solutions. And sometimes the option will be all real numbers. I just want to make sure that you know both answers would work. Because sometimes they'll give you this option and not that one when you're taking a test. Sometimes it'll just give you the other option and not both. Yes?
So basically, if they're both the same, then
Infinitely many. Yeah, what that means is that if I was to graph these lines, it would look like that. Both lines would be the same, sitting right on top of each other. Okay? So this is my one special answer. Nope. Okay, that's one of my special answers. All right, let's go ahead and look at problem number 4. Oh, for this one, yeah, because negative 3 is equal to negative 3, right? And you can't do any more from there. Okay, because if I add it, it would be 0 equals 0. We don't have to do 0 equals 0. We could stop at negative 3 equals negative 3. So let's go ahead and look at problem number 4. Okay, it's still set up where it isolates my y. And I can go ahead and bring this y and substitute it in that position there. So I'm going to rewrite my equation. I have minus 6x plus 3. Instead of y, I'm going to start my parentheses, and I'm going to write 2x minus 5. And then end my parentheses, and finish my equation with equals negative 7. Okay, So I'm looking at my list, and it says to eliminate parentheses, and I'm going to use my distributive property to do that. So I'm going to multiply 3 times 2x, and I'm going to multiply 3 times a negative 5. Okay? My negative 6x isn't part of that distribution, so I'm just going to bring it down. Minus 6x. What is 3 times 2x? Positive 6x, right? What is 3 times a negative 5?
Negative 15.
Minus 15. And then bring down my negative 7. Do I have any like terms to combine?
Yes.
What can I combine? Okay, so what happens when I add 6x to negative 6x? It becomes 0. So that leaves me with negative 15 is equal to negative 7. Is negative 15 equal to negative 7? It's a true statement. I have minus 15 is the same as minus 7. Let's look at the number line. Is negative 15 in the same spot that negative 7 is? So are they equal? They're not equal. So we're going to cross off that equal sign like that. We're going to slash it. And that tells me that negative 15 is not equal to negative 7. So can I have an answer that works? So what's my other special answer? So my answer for this one's going to be no solution. That's my other special answer. I'm either going to have an ordered pair, which I can write as x and y. I'm going to have a no solution because they don't equal. Or I'm going to have infinitely many solutions or all real numbers because they're identical. The line is right on top of each other. Yep. No, they're not all going to be infinitely many or all real or no solution. You are going to have a couple with answers in the form of an ordered pair, x, comma, y. Okay? So those are your 3 choices. Infinitely many, no solution, or an ordered pair. Okay, so we crossed off problems 1 and 2. You have 2 on this side and 6 on the back. Ordered pair is x and y, like that. So you have a number for x, a number for y, like yesterday.